Hey guys, last time we had a look at this scenario here where we used the general proportion, general probabilities we know associated with the normal distribution, where between one standard deviation either side of the mean we have about 68%, two standard deviations either side of the mean we had about 95%, and three standard deviations we had about 98%. And we worked out some specific problems associated with this particular scenario. We're going to have a look at how technology can help us with that now, see how close our ballpark was. And to do this, we use a function in our distributions called normal CDF. Let me write that down. The normal CDF. Once again, that C, remember, we associate with cumulative. And the reason we only use CDF here is because we're looking at probabilities that are greater than or less than or greater than or less than combined. So we're always looking at cumulative, like inequalities, less than, greater than, when we look at the normal distribution, not the probability of x equals 85. Okay, so it's always the normal CDF. Now when we use technology to enter that, what we do, we enter the minimum value. So in this case, the minimum value of our probability range is 80. We enter our maximum, and of course we have to tell the calculator our mean and standard deviation. It's got to know that. Okay, so then I put in my mean and my standard deviation. Okay, so for this one, let's have a look at this one here. Let me turn this on. We go to distribution, so second variables, normal CDS right up the top there, so let's open that. Now for our minimum value, this time we're going to put in 80. So we've got 80, comma. Now our maximum value is tricky because we don't have a particular maximum value, but this is how we can use the calculator to put it in. Up here, a maximum, if it just goes infinitely on this direction, we're going to tell our calculator to do this. 1 times 10 to the 99. That's the biggest number our calculator can do. And for minimum values down here, we're going to tell it to do minus 1 times 10 to the 99. That's how our calculator can deal with infinitely small and infinitely large values. Now to actually put that into our calculator, we use our EE key there. So in this case, we want a very large number. So I just select second EE and I put 99. So there's my maximum value where there's no endpoint, it's just greater than 80. So min, max. Now I enter my mean, which in this case is 80, and comma, my standard deviation, which was 5. Close that. Let's have a look what we, oh, look at that, 49.999%. And of course what we got last time was 50%, which we know. So with technology, we've got 49%. Well, oh, hang on, let's round that up. That's 50%. Okay, so let's have a look at the next one. All right, approximately what percentage of people earn between 75 and 85? So this is what we're after. Let's start setting up our probability distribution. I can write that out using my discrete random variable notation. So this is what I'm going to do. X is less than or equal to 85, but greater than or equal to 75. So now I can put in my normal CDF. So I'm going to do min, max, mean, standard deviation. So let's go in again. Normal CDF. This time we have a distinct min and max, so I can just put 75, comma 85. My mean once again is 80. Standard deviation 5. Last time we got 68%. Let's see what we get here. Oh, look at that. 3 sig figs, 68.3%. So we can write that down now in black this time. Technology gives us 68.3%. Look, very, very close. Well, let's go to our next one. Right, pause at any time, guys, and go ahead and have a look at these. Pretty straightforward. Once again, here we're going to set up our distribution. we want x to be less than or equal to 90, greater than or equal to 70. So we're going to use our normal CDF, second variables, min, what was it this time, 70, 90, our mean 80, and our standard deviation of 5, got all that in, 95.4. Okay, there we go, 95 to 3 sig figs on here, we have 95.4%. Or you can just write 0.954, leave it as a decimal, that's fine. Alright, let's have a look at another one. Percentage of people below a 75. Okay, so let's set up our distribution. We want the probability that our score is less than or equal to 75. Whether it's just less than or equal to really doesn't make any difference. Alright, so to enter that this time, let's just write down what we're going to have. Norm CDF. Right, our min this time is a large negative value. So we enter negative e to the 99. Negative. So that's minus 1 times 10 to the 99. The largest number that our calculator can deal with. Our max 75, mean 80, standard deviation 5. So just a little one there to practice your large negative values. So let's go in again. Normal CDF, always CDF. So negative e to the 99, there's our minimum value, 75, mean of 80, standard deviation of 5, and last time we got 16%. Oh, look at this, to 3 sig figs in this situation, we've got 15.9%, or once again, 0.159, same thing. Okay. And last one, let's set up our probability distribution here. What percentage of people earned above 90? So we want the probability of our distribution to be greater than or equal to 90. So this time, min 90, our max, using our e to the 99. So last one, normal CDF, min of 90, max of e to the 99, so second, comma, e to the 99, comma, mean, standard deviation. Always got to put mean and standard deviation because it's going to change for each distribution. We've got to tell the calculator what's our mean, what's our standard deviation, so it can calculate it for us. And let's have a look. That's 2.27%, or 28%. We got before 2.5, so 2.28%, and that's what our calculator tells us. Now, it's always good to have this ballpark, but of course from now on, guys, you will be using technology to calculate these percentages. Okay, have fun.